In episode 63, titled Understand Cloud Deployment and Service Models Clearly, we turn cloud vocabulary into plain choices that shape controls, responsibilities, and the evidence you must be able to show. The promise of elastic capacity and rapid delivery only holds when you can state who secures what, where boundaries live, and which guardrails enforce the promises you make to customers and auditors. Rather than treat the cloud as a mysterious elsewhere, we will describe concrete models in language your teams can act on, then connect those models to identity, logging, networking, encryption, and cost controls that survive real projects. By the end, you should be able to point to a workload and say, with no hand-waving, which party patches, which party hardens, which keys protect which data, and where the logs will prove it.
It helps to anchor definitions in what you actually touch. Infrastructure as a Service, IaaS, delivers raw compute, networks, and block or object storage. You create and secure operating systems, patch middleware, configure firewalls, and own every agent and key you deploy. Platform as a Service, PaaS, abstracts the operating system and much of the middleware. You configure runtimes, secrets, ingress, and scale, while the provider patches the platform beneath. Software as a Service, SaaS, offers finished applications. You control tenant configuration, identity, data retention choices, and access reviews, but you do not harden the servers. A helpful rule is control versus configure. In IaaS, you control the host, in PaaS, you configure the service, and in SaaS, you configure the tenant. Your security plan must match that verb. Deployment models change how those verbs travel. Public cloud pools shared infrastructure behind strong isolation, which makes connectivity simple but requires disciplined identity, segmentation, and egress governance to keep tenants from drifting into flat networks. Private cloud centralizes control for a single organization, often with tighter governance and custom integrations, but inherits all the patching and capacity risks of owning more layers. Hybrid cloud connects owned environments to public capacity, which raises trust questions at the seams. Routes, name resolution, certificate authorities, and change control must treat the interconnect like a formal boundary. The implications are not philosophical. They decide where inspection lives, which keys cross which links, and who approves a new path that could bridge two trust zones without review. Many teams adopt multi-cloud for resilience, vendor negotiation, service fit, or geography, but every additional provider multiplies identity, logging, and networking work. To keep complexity from erasing benefit, define minimum standards that every cloud must meet before a project is allowed to land. Identity must integrate with your provider of record and support conditional access and short-lived credentials. Logging must export control plane, data plane, and audit events to your central analysis within minutes. Networking must deliver non-overlapping address spaces, explicit egress controls, and private service endpoints for sensitive flows. If a provider cannot deliver those three at parity, confine its use to low-risk use cases until it can. For teams, this is liberating. The catalog of ready clouds is small, and the rest are experiments, not production landings. Core services carry predictable security expectations that vary by model, and clarity here prevents surprise later. Compute in IaaS expects hardened images, patched kernels, endpoint detection and response agents, and host firewalls you manage. In PaaS, compute expects runtime constraints, image or build attestation, and secrets injection with zero plaintext and pipelines. In SaaS, compute is invisible, so the expectation shifts to tenant isolation proofs and role scoping. Storage in IaaS expects encryption at rest with customer-managed keys and explicit bucket or disk policies. In PaaS, storage expects service-side encryption with customer keys and network private access. In SaaS, storage expects tenant data classification, retention, export controls, and write-to-erasure workflows. Databases and functions follow the same pattern. The closer you are to the metal, the more you harden and patch. The closer you are to the tenant, the more you constrain identity, validate configuration, and verify isolation. Shared responsibility lines must be written, not assumed, so the gaps become visible before an incident. In IaaS, you patch operating systems and managed software. The provider patches hypervisors and physical hosts. In PaaS, the provider patches the platform and database engines. You patch your application code, rotate credentials, and secure connection strings. In SaaS, the provider patches everything under the hood. You govern users, groups, multi-factor enforcement, data lifecycle, and third-party connections. Hardening follows the same split. Baseline images and agents are yours in IaaS, service policies and private endpoints are yours in PaaS, and tenant security features, roles, retention, device controls are yours in SaaS. Keys and monitoring bridge all three. You should own customer-managed keys wherever feasible and receive auditable logs in a place you control.
Identity is the first control plane, and cloud-native roles and policies are where least privilege either exists or is theater. Bind accounts to your identity provider with federated, short-lived tokens. Avoid standing users in cloud consoles except for break glass. Express permissions with fine-grained roles and resource-scoped policies, then add conditionals, source network, device posture, time windows, tags to narrow power to context. Service-to-service access should rely on workload identities rather than long-lived secrets, and rotation should be automatic with receipts. Reviews must be mechanical. List who has owner-level privileges, who can create new identities, who can change key policies, and who can open routes. When identity and authorization are crisp, everything else improves because every action is traceable to a named role in a named context. Standardized landing zones make good intentions repeatable. A landing zone is a pre-wired project or account with shared guardrails, network patterns with non-overlapping address spaces, private endpoints to core services, encryption defaults that insist on customer-managed keys, mandatory tags for ownership and data class, and cost control hooks that alarm on drift. It includes baseline roles, break glass procedures, logging pipes, and detective controls that trip when someone tries to create a public bucket or a wide security group. Teams deploy into these zones through templates rather than inventing their own foundations, which keeps reviews focused on the application, not the scaffolding. The result is dull, predictable infrastructure, exactly what you want beneath interesting software. Telemetry is your receipt drawer, and in the cloud it has three streams. Control plane logs tell you who created, changed, or deleted resources and with which role. Data plane logs show access to storage, databases, and functions. Audit logs aggregate sign-ins, failures, and administrative actions across organizations and tenants. Route all three to your central analysis with durable delivery. Normalize timestamps to trusted time and enrich with tags so a single event already knows its owner, environment, and data class. Keep near real-time views for responders and retained archives for investigations and compliance. When an engineer asks who opened this bucket, when, from where, and with what justification, the answer should be a query away, not a week of emails. Validation prevents drift from masquerading as innovation. Policy as code lets you express guardrails as evaluators that run in pipelines and at deploy time. No public storage unless a specific exception tag and approval exist. No security group with broad ingress. No database without encryption and backup policies attached. Pre-deploy tests spin up temporary stacks, exercise basic flows, and prove logging and alarms fire is expected before production sees change. Templates carry version numbers, and exceptions require tickets with owners and expirations. Over time, these checks become muscle memory. Engineers see violations locally, fix them with code, and ship with confidence because the same rules will run again in integration and production. Several pitfalls repeat across providers and projects, and each has a preventative control. Public buckets and file shares creep in when defaults are lax. Set organization-level policies that disable public access unless an exception is granted. Then alarm on any change. Flat networks appear when address plans are improvised. Reserve ranges, segment by intent, and deny all inter-segment traffic until a rule justifies it. Orphan accounts arise when projects close or owners leave. Require tags for owner and cost center, alert on unused identities and stale keys, and run a quarterly disable then delete job with a short observation window. None of these fixes are glamorous, but each removes a category of headline-ready mistakes. A short scenario shows these ideas working together. A team launches a new analytics workload using an approved template in a standardized landing zone. The template creates a private network, attaches a managed database with encryption at rest using customer-managed keys, deploys compute with hardened images, and wires control plane and data plane logs to your central analysis.
Identity binds the service to a workload role that can read from a single storage path and write only to its result bucket. Egress is limited to the managed update service and a metrics endpoint. Policy as code checks pass in the pipeline, a temporary stack proves alarms and logging work, and the production deploy proceeds. The team receives a one-page What You Own summary application, data classification, keys rotation schedule, runtime secrets, and knows exactly where their responsibilities end and the providers begin. A quick comparative review cements duties. In IaaS, your team patches hosts, hardens images, deploys agents, manages keys, and proves segmentation. The provider secures facilities, hypervisors, and base hardware. In PaaS, your team secures code, secrets, and configuration. The provider secures runtimes and platform patches. Both share monitoring, your signals feed from the service, theirs prove platform health. In SaaS, your team governs identity, roles, data lifecycle, and integrations. The provider runs the whole stack and publishes tenant isolation, encryption, and compliance attestations. Both parties must exchange logs that demonstrate the promises were kept. Writing these lines down and revisiting them per workload prevents "I thought you had that" moments. We close with an operational nudge that turns clarity into habit. Create a one-page cloud model cheat sheet that lists IaaS, PaaS, and SaaS down one side, and maps guardrails across the top: identity, network, encryption, keys, logging, patching, and monitoring. For each cell, write the single sentence that states who does what and which artifact proves it: role names, policy files, key policies, log destinations, patch cadences. Keep the sheet beside your landing zone templates and require it in architecture reviews. When new teams join, they learn the language in minutes. When auditors arrive, you hand them the map and the receipts. Clear models, crisp guardrails, and visible evidence are how cloud stops being a buzzword and becomes an environment you can run safely, repeatedly, and at speed. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.